Suppose you have taken a solenoid like this, that is also we say it that is a inductor here having self inductance L. When current I is flowing through this solenoid, what happen? A back EMF is induced which opposes increase or decrease of the strength of current in the coil or in the solenoid. Now, see here, the role of back EMF is simply to oppose the increase or decrease of the current. So, due to this opposition, some work is done in establishing the current in the coil or in the solenoid. Suppose at any instant current I is flowing, then the rate of doing work that can be given d upon dt, dw upon dt is equal to magnitude of EMF into I. And see, this work done which is stored in establishing the current in the inductor is known as magnetic potential energy. So, we can write here, you know, dw is equal to this. So, we can write dw upon dt is equal to here L di upon dt into I here, and we can write dw is equal to Li di. Now, the total work done in storing the in establishing the current from 0 to I is that is I di. We can integrate it. So, when we integrate it, we can get this one W is equal to L here I square by 2 on integration. So, this is the total work done in establishing the current in the inductor, and this is known as your magnetic potential energy. This is called magnetic potential energy is equal to half Li square. And we can also here calculate energy density. So, for calculating energy density, we can take total energy divided by volume. So, energy density is equal to half Li square divided by volume of solenoid. So, we know it L we can write here mu naught and mu naught n square A by L. Already we have derived this formula, and we know it B is equal to mu naught n I. So, that can be written mu naught n upon L into I. This is the magnetic field. So, I can be written here L B upon mu naught n. This is the I. And volume we can write here area into length only. So, we will be replacing all these things in this one. When we replace all these things in this formula, so we will be getting energy density is equal to half, this is here mu naught n square A upon L. In place of I we can write here L square B square upon mu naught square n square, and whole upon volume. So, that was into A L. Now, we can cancel in this whatever is getting cancelled here. This is L, this is L, this L square, this n square, A and A, and there is a mu naught and mu naught square. So, we will be getting half B square upon mu naught. This is the energy density of the solenoid. And we have done also like this formula in electrostatics, it was their energy density in capacitor, and in capacitor that was here half epsilon naught E square, and we have that was the half epsilon naught E square, where electric field was there, and here is the magnetic field in place of that, and here the constant was your epsilon naught, and here the constant is your 1 upon mu naught. So, this formula is actually analogous to the formula of the energy density in capacitor.